All right, so I'm trying to do number 73 in 11.6, which says verify this thing. Okay, so I'm supposed to verify that the sum of these logarithms with funny fractions is 0. Okay, how do I do verify problems?
You put in some numbers and see if it works.
That's actually a really good engineering step. So normally I would tease engineers because they would try two numbers, and if it works, they'd be like, yeah, it's a fundamental physical law. Okay, don't quite do that. I want to know this works for all the x's, right? So if I plug in like 2 or 3, actually, if I plug in like 2 or 3, I'm going to personally have a hard time kind of evaluating this, right? I could cram it in a calculator and maybe get the right answer or see that it was 0 if I tried this for a couple x's. But I'm going to have a hard time even typing this into a calculator, right?
Are they all going to be the same? You multiply.
So I want to start with this stuff, right? And see if I can fiddle it around to get to 0. You guys see that? So that's basically going to be what I'm going to try here. I'm going to take this left-hand side and see, is there a way I can kind of monkey this around and get 0 out of it?
Yeah, so you're going to put in some numbers and see what works.
No, we're not going to put in some numbers and see what works.
Do you multiply them?
So, I don't know. I have log rules, right?
Yeah.
Okay, so let's fiddle with some log rules for a minute.
Multiply something.
Okay, so log rules say that when I've got all this junk added together, I could multiply, right? Okay, so I could say this is this stuff, right? I'm not talking about the right-hand side. I'm really wondering, is this 0? I'm pretty sure it is because the book told me it was. But right now I'm just going to play with this part. So just the right-hand, or just the left-hand side is log of,
Multiply everything on the top, everything on the same.
okay, so there's a 4/5 to an x, then there's a 5/3 to an x, and a 3/4 to an x, right? How'd you get 60 over 60?
I was saying, there's a 4, 5, and
Okay, because they're all the same power, right? So I can regroup that as log of 4/5 times 5/3 times 3/4, all that junk to the x, right?
Are
And-
they, sorry.
No, go for it.
Are they gonna be like this on the test though, or it's gonna be like something like that, or are we gonna actually have to do math? Like this, I'm saying like we can recognize that and there's like a shortcut to it.
So, to be totally honest with you, I would say this is the first time we've done the math. Like previously we've been mostly doing kind of arithmetic or easy algebra things.
Yeah.
And this is maybe the first time that we've seen something that requires a little bit of creativity. This is what real math looks like. It actually looks more like these verify things and less like this calculate stuff. So I feel like these questions are a little bit hard actually for the level that we're doing here.
I'd say
Cool.
These are easier for me to
Awesome. You should study mathematics.
understand.
We should talk about it though, really. So let's see. I got this guy, and then you guys have noticed that that's, right, log of 60 over 60 to the x, right? Okay, what's 60 over 60? 1. So this is log of 1 to the x. What's 1 to the x? Yeah, it's 1, right? No matter how many x's I multiply together, even if I multiply 0 x's together, right? Still got 1, yeah. So this is one of our exponent rules, right? Is that 1 to the whatever is 1. Okay, so we got log of 1. What's the log of 1?
0. It is?
Is it? I don't know. Tell me.
Yeah, it's
Yeah,
verified
it
it
is.
was so.
Okay, so 1, we're trying to verify that it is, so it probably is. 2, why would log of 1 be 0? Right? This thing is asking a question, right? This is wondering, e to this something is 1, right? What's this something I can put in an exponent to get 1 out? 0. You guys see that? Cool. So in the end, we verified in our work, right? What do we circle here? Everything. This whole process is our work. You guys see that? And they told us the conclusion. So 0 is not the answer, right? That's not the thing I circle. The thing I circle is this whole process. And if I wanted to justify some stuff, which maybe would be a good idea, I would say something like, this is a log rule, right? This one's an exponent rule. What happened there to there? What? Yeah, simplify. 3 times 4 times 5 is 60, or whatever, right?
If we circle the wrong thing on this estimating,
I'm not so concerned about you circled the wrong thing. If you wrote the rest of this and happened to circle 0, I think I'd probably give it to you. How about this step? Yeah, that's a cancel or simplify again, maybe. How about this step? Yeah, that might be a solve, simplify, exponent rule. 1 to the whatever is 0, or sorry, 1 to the whatever is 1. And then this step is log of 1 is 0. You guys see that? This is a little bit how high school geometry kind of class goes, right? You do something, then you write in the margin how you justified that. Then you do something else, you write in the margin how you justified that. That's a little bit what we're doing here. Cool? Not